So here is a quick explanation of what you need to do with your pieces of paper. Go ahead and make sure that you are cutting around the entire perimeter as well as all of the pieces in between. So anywhere where there's a solid line, that's where you need to go ahead and cut. Once you're done, you can see at the very top you have page 1, page 3, page 8, and you should have a total of 8 pages. Make sure you put it in numerical order, and you can actually see that each paper is going to be slightly bigger than the next, and so it should be from smallest to largest so that you can see what the categories are, and the categories are going to be down here. This piece of paper that says properties of exponents, this is going to be like your cover page, okay? So when you're done, you can actually see the example that I have. The teacher or substitute should have what it should look like as a final product, and it shouldn't take longer than like maybe 5 minutes, but when you're done, make sure you staple at the very top. I recommend stapling once on the right hand side and once on the left hand side. A quick note for the students who are not in class and don't have your own copy, you can always either print this off yourself, or if you don't have a printer, you can take some pieces of paper and just sort of like fold them over each other and create the same idea of what we're doing right now. If you are curious of how to do that and maybe you're not quite sure what the steps are, you can always Google how to create a flip chart. So on the first page, it talks about 0 exponents, and there's a little bit of notes that I want you to, just copy down or maybe add a little note to it. But at the very top, it says any number raised to the power of 0 equals 1. And really, it's any number or variable, because a variable is a number, or represents a number. And so we have 2 examples over to the left-hand side, which I'm going to highlight. You can see x to the 0 power is equal to 1, because anything traced to the 0 power is 1. And then 5 to the 0 power, and they could have picked any number, -1, 45, 1,096,000, or whatever. And so over on the right-hand side, we have some examples. We have 8 to the 0 power times x to the 4th power. Well, I know that 8 to the 0 power right here is going to be equal to 1, and then times x to the 4th, well, anything times 1 is itself, and so our answer is going to be x to the 4th. The example beneath it is the same idea. We have x to the 3rd power, or x cubed, times y to the 0 power. Well, it doesn't matter that we now have a variable. It's anything raised to the 0 power. So this 0 is currently touching the y, so that is going to cause that to be a 1. And again, anything times 1 is itself. So x to the 3rd power would be our answer. So the second page has negative exponents. And negative exponents, we've already sort of talked about. We briefly mentioned it on Friday when we went over the lesson. But at the very top, it says to simplify, you need to change the sign of the exponent and use the reciprocal, which is what I had mentioned. And so we had an example like this that I just put a box around, where it was a number or a variable, x to the -2nd power. And I said what we're going to do is we're going to flip it, because remember, technically it's over 1. And so the reciprocal of that would be 1 over, and then the 2 follows the base, or follows the x, and when you flip it like that, it changes to positive. But what I didn't mention was that the same exact thing happens the opposite direction. So if you look at the example below that, which I'm going to put a little box around, we start off with 1 over x to the -3rd. So this negative right here is going to go ahead and move upward, or if we were to take the reciprocal, we would flip it, so it flips to the opposite side, which is now the numerator. So this is going to move upward, and so again, the exponent, as it moves, changes to positive, and it sticks with that x to the 3rd power. So let's apply this to some practical examples. If we look over on the right-hand side, we have 5 to the -3rd power, 5 to the negative third. This is not okay to have a negative exponent, so we need to flip it so that it will turn positive. So it's going to be 1 over 5, and then we carry the 3 with the 5, and it changes to positive. When I taught Algebra 1, I used to say that this is like an apartment building, like you're either upstairs or you're downstairs, and some people like being upstairs and some people like being downstairs. And you can tell if somebody likes where they live depending on whether they're, a positive or not. So if you have a negative number in the top of the apartment, you've got to move it downwards. And vice versa. If you have an unhappy or negative number in the bottom, you've got to move it upstairs. So, with this one, we can actually go a little bit further before we move on to the next one, because we actually know what 1 over 5 cubed is. 5 cubed is 125. So I can write this as 1 over 125. So then the one next to it is very similar, but I wanted to make sure that I went over this because sometimes you will see parentheses and sometimes you will not, and I just want to make sure we remember that when we do not have parentheses, we only change the number that the exponent is touching. And currently, that exponent is not touching a negative 5. It is actually touching a positive 5. And so when I flip this, I'm going to keep the negative where it's at, okay? And I'm moving the 5 to the third power, 5 to the negative third power, downstairs it's flipping, it's doing the reciprocal, and then our answer is going to be very similar. It's going to be negative 1 over 125. And so another way to think about this, because, it looks like a negative 5. The other way to think about this is think about it as a negative 1 in front, and it's multiplying with the 5. That's another way you can think about it so that you can make sure you don't accidentally bring that negative 5 downward. Okay, so as I mentioned before, when I was in Algebra 1, I would mention it as, upstairs and downstairs, and that's fine. For me, for you guys, I'm just going to say flipping. So if it helps to think about it as upstairs and downstairs, then that's great, but I'm probably not going to refer to it that way again. I do want to do the one beneath these problems, which is 2x to the negative second, y cubed, all of that over 4z to the negative fourth. All right, so first things first, I'm actually going to deal with the normal numbers. I got 2 over 4. I can rewrite that as 1 over 2. All right, and then I can deal with my variable x. Okay, so when I deal with my variable x, I can see it has a negative exponent, so it needs to flip. So it's going to go downstairs. All right, so I'm going to rewrite that downstairs. All right, then I go to the next one, y to the third power. He's positive. He's pretty happy, so he's going to stay where he's at. And then our z to the negative fourth is currently in the denominator. It is a negative exponent, meaning it needs to flip. So this is going to go upstairs. So I'm going to rewrite it next to the y. It'll be z to the fourth power. And I personally like to make it look nice. So I'm actually going to rewrite this, and I don't need the coefficient 1 because it's already understood to be there. So my numerator is going to read y to the third, z to the fourth, all of that over 2x squared. And that is how you deal with negative exponents. So multiplying, not radicals, but exponents is what we're going to talk about next. And I believe this is on page 5. So we're actually skipping a couple of these, but it's not like super important. We'll go over it later. Yes, so page 5, it's talking about multiplying. And at the very top, it has some really good advice. It says to multiply the terms, you must have the same base. Okay, so if we had x and y, we would not be able to combine those. But let's say we had 2 x's and 1 y. Well, we would be able to combine the 2 x's because they have the same base. The sentence underneath it says, when multiplying, the base stays the same and you add the exponents. In fact, it's actually bolded for you. So when you're multiplying, you add exponents. And if you look at the example beneath, you can see we have the same base, which is x. X is our base, okay? It's the bottom of our little picture, if you will. So it's the base of my exponent. I am going to add my exponent. So 5 plus 7, which is what you see over here, this is 5 plus 7, I'm going to add that up and I'm going to get 12. So I simplified this by adding my exponents, and my final answer is x to the 12th power. All right, so the example beneath it is the same idea. It's just adding more values, adding more information for you. So we have a lot of information, and the easiest thing to do is sort of break it apart. We have 4 times 2. Those are the normal numbers. You did that back in elementary. So if we multiply that, that's going to be 8. But then we have our exponents to deal with, or our variables with exponents to deal with. So we have x, so I'm going to highlight my x's, and I need to add up 3 plus 2, which is what I'm doing right here. 3 plus 2 equals 5. Then I do the same thing again with my y's. Here are my y's. All right, I'm going to add my exponents, which is what I'm doing here, and I'm going to get 2 plus 4 is 6. So I'm going to write that as y to the 6. And so I just put everything together once I'm done, and that's my final answer. 8 from the numbers, x to the 5th from the yellow highlighted portion, times y to the 6th, which is the blue highlighted portion. So the examples beneath are the same idea. The first one's very easy. There's only 2 things to really look at. We have 4 times 3, which is 12, and then we have x times x to the 4th. Well, there's an understood exponent of 1 here with this x. So remember, if you don't see an exponent, it's an understood 1. And now I can easily add 1 plus 4 and get x to the 5th. And so this is my answer. Underneath, we have a lot of parentheses, but remember, parentheses just means multiplication. So even though they're all there, we can really sort of ignore it. So I'm going to look at my numbers first. I got 3 times 2. That's going to give me 6. Then I'm going to go down the line and highlight all of my x's and add up all these exponents. 7 plus 5 is 12. 12 plus 3. 7 plus 2, not 12. 7 plus 2 is 9, and 9 plus 3 is 12. So this is going to be x to the 12th power. And then I'm going to do the same thing again with my y's. So here's my y's. Again, I have a variable with no exponent, so there's an understood 1 there. And 5 plus 1 is 6. And so this is my answer. Same thing below, except now we're going to have something slightly different. So here are x's. We're going to add 3 plus a negative 5, okay? No big deal. We add 3 plus a negative 5, and we get x to the negative second power. Then we do the same thing again with our y's, okay? This is 2 plus 3. Everything's normal here. And we get y to the 5th. Okay, now, remember our tab before we, at the very beginning with the negative exponents? When you have a negative exponent, your answer is not done. You have to flip that number or flip that variable. So the y is perfectly fine. It's positive. It's good to go. But the x has a negative 2 exponent, and so that one's going to flip to the denominator. So I'm going to move it downwards, and the y to the 5th is going to stay where it's at. So it's going to be y to the 5th over x to the 2nd. All right, and so if you're thinking about it as like the apartments floors, as I've mentioned before, everybody starts off on the top floor. So that's why we moved the x downward as opposed to upwards, because everybody starts on the top floor, if you will. Okay, last one beneath it, negative 2 times 3 is negative 6. X times x, okay, we have x to the 3rd power and x to the negative 4th. Well, 3 plus a negative 4 is a negative 1. Our y, that's going to be negative 2 plus 5. That's going to be a positive 3. And then we don't have anything with z, so I'm just going to carry that over, negative 2. All right, so this time I have 2 things that are fine. I have negative 6, no big deal. That's not an exponent. That's just a number. Numbers are allowed to be negative. It's exponents that are not. So the negative 6 is fine, and so is the y cubed. So those are going to stay upstairs because that's where everything starts. And I'm going to move my x to the negative 1 downwards and my z to the negative 2nd power. So the numerator is going to read negative 6y to the 3rd power over x to the 1st power. And if I want to put 1, I can, but it's not super important, times z to the 3rd, or to the 2nd power. Yeah, that's right. To the 2nd power. So just like multiplication, division is going to be very similar, but just the inverse. Just like multiplication and division are inverse operations, when we move from the multiplication tab to our division tab, which I believe is page 6 or something, we are, instead of adding our exponents, we're actually going to subtract our exponents, which is what that little top sentence says at the, and I'll highlight it. It says when dividing, the base stays the same and you subtract your exponents. Extra highlight there. And it's already bolded for you and everything. So the example below has x to the 8th power over x to the 4th power. So it shows that we are subtracting them, all right? And you can think about your fraction bar as one big minus sign. That's usually how I remember it. And then you are going to put your solution in the floor, if you will, in the floor of whichever one was higher. So our numerator, or the upstairs, was higher with 8, and so it's going to stay upstairs. If it had been reversed, let's say it was x to the 4th over x to the 8th, well, the process would still be the same. X to the 4th minus the 8 would be 4, technically negative 4. But because this 8 is larger in the denominator, we are actually going to put our solution in the denominator. And here's why. So technically, the math behind this would be x4 minus 8, which would equal actually a negative 4. So that's why with a negative exponent, we know we would have to flip it. So this would end up being 1 over x, and then the 4 follows the base, the x. And so we end up with the same answer. It doesn't really matter how you think about it, but hopefully one of those explanations will assist you in that process. So again, we have, let me go ahead and erase this actually. Maybe not all of it, just some of it. Okay, so underneath we have an example, 2x to the 7th over 6x to the 5th. And so obviously, first things first, I can go ahead and deal with the 2 over 6. That's going to give me 1/3. Okay, and really when you're doing this, I would just start off by putting a fraction bar so you can sort of get an idea. But it's going to be 1 over 3. Then we deal with the exponents of our x's. Well, 7 minus 5 is 2. The 7 is bigger, so I'm going to put my x squared in the numerator. All right, so that is what I'm going to have, and I'm going to rewrite it so that it's nice and pretty. X squared over 3, and that is your solution. If you leave it in this format over here, let's see. If you leave it in the format over here, that's fine. I'm not going to mark anything wrong. Underneath, same idea, we have 12 and 3. So let me write my fraction bar. 12 over 3 is going to be 4 over 1. And then I can look at my x's. X to the 1st power and x to the 5th power. Well, 1 minus 5 is technically negative 4, all right? But my 5 is bigger in the denominator, so I'm going to put it x to the 4th in the denominator. And because it moved, it's now positive, all right? So originally 1 minus 5, that is negative, but when it moves downstairs or to the denominator, that's when it becomes positive. All right, y to the 4th minus y squared, or really divided by, and so it would be 4 minus 2. That would be 2, and the 4 is bigger, so I'm going to put my answer in the numerator where that 4 originally was. And then finally, my z's. 2 minus 1 is 1, and obviously 2 is bigger than 1, so I'm going to put my answer in the numerator. Again, I'm going to rewrite it so it's nice and pretty. It's going to be 4y squared times z over x to the 4th. Again, I don't need to put my leading coefficient of 1 because it's already understood. All right, last one. We have a little bit different thing happening here. We start off with some negatives. So what I'm going to do is I'm actually going to rewrite this so that I can get rid of my negatives, and I'll deal with everything else later. So as you can tell, I have this negative 5 that needs to go downwards. I have this negative 1 that needs to go downward, and a negative 3 that has to go upward. So I'm going to rewrite this where everything that doesn't move is written first. So I'm going to do 6z, all right? And then I'm moving upwards a z to the third, so I'll do that in a second. But in the denominator, the things that are staying are the 36 and the x to the fifth. Okay, so now I'm going to write what moved and where it's going, basically. So in the numerator, I said earlier, the z to the third power is going upwards, but in the denominator, I'm going to have x to the fifth and y to the first. And then upstairs, I have z to the third power. Okay, and now you can sort of see that if two of these items are in the same floor, then they're actually multiplying, and when you multiply the same base, you add the exponents, okay? So this one's a little bit tricky because it looks like it's going to be division, but then it ends up switching on you and ending up as multiplication, which is addition. So I'm going to highlight these two z's over here. I'm going to add those up, and I'm going to, I should have done separately, but it's fine. I can also see I'm going to have to add up the exponents for my x's here, and then of course after I'm done, or maybe at the beginning, probably would be a good idea, I need to reduce 6 over 36. So this is going to be my fraction bar, 1 over 36, and when I combine my z's, 1 plus 3 is going to give me 4, so that's going to be my numerator. My denominator is going to be that 6 that I mentioned. 5x to the fifth times x to the fifth, add the exponents. 5 plus 5 is 10, so it would be x to the 10th, and then y to the first, because I don't really have to. And if I wanted to, I can rewrite this where I don't have my leading coefficient of 1, and I don't even really need an exponent of 1 with the variable y. So I would rewrite it as z to the fourth times 6x to the 10th power times y, and this is my answer. So find the tab that has a power to a power. I think it's page 6 or something like that. But it says when raising a power to a power, you are to distribute your exponent. You are to distribute your exponent. The base stays the same, and you are going to multiply the exponents. So this is when we actually don't have, if you look right here, we don't actually have two bases. We have one base to the fifth power, x to the fifth, and then on top of that, we have a exponent on the outside, an additional exponent of 6 right there. And so all they're saying is that when this occurs, what you need to do is multiply your two exponents. So if you're multiplying with the same base, you add your exponents. If you are dividing with the same base, you are subtracting. But if you just have one base and two exponents, that's when you multiply. And so that's how they got that 5 times 6, which equals 30. And so the one beneath that is even more complicated. And so what you need to do at the very beginning, and this is how I taught it for you guys on previous ones, is since we don't have any plus or minus signs, we don't have to deal with Pascal's triangle, we can consider this as a form of the distributive property. So we distribute that. We get 2 to the fourth power, x to the, 3 times 4 is actually going to be 12, which is what we get there, and then y, 2 times 4, which is going to be 8. And obviously 2 to the fourth power is going to give us that 16. So this is our final answer for this example. So in the example below, we can again see no addition or subtraction signs, which would indicate Pascal's triangle. So we're taking our exponent here and we are distributing it to everything. All right, so with the first one, it'll just say 3 to the fifth power, and then when we distribute the 5 to this 3 right here, we're multiplying. So that's going to be x. 3 times 5 is 15. All right, distribute here to the y second. Y squared, 2 times 5 is 10, and then we distribute one more time to the z to the fourth power, and 4 times 5 is 20. So the last thing we have to do is just make sure that all of our numbers are done, which, well, we have to deal with 3 to the fifth. So 3 to the fifth power, if we plug that into our calculator, is going to be 243, and then we carry all of these exponents over. X to the 15th, y to the 10, z to the 20. All right, the one beneath it, it's actually broken up. You can see that we have one exponent on the outside here, which we distribute. All right, so that would give us x 3 times 4 is 12, y 2 times 4 is 8. And then the next one is squared, so I'm going to distribute that squared to everything. Negative 2 times, or to the second power, is actually going to give me a positive 4, so I'm going to put positive 4 here. X, technically it's understood 1, so 1 times 2 would be 2. And y cubed, raised to the second power, that's going to be 3 times 2, which is 6. All right, so now I just have all multiplication. So remember, multiplication is when we add exponents, if they're the same base. So let's look if we have that. Well, I have an x here and an x here. So I'm going to put that 4 in front really fast. And because you should always put like your normal coefficients in front. So the 4 goes in front. My variable x is what I'm looking at, and I'm adding my exponent. So 12 plus 2 is 14. And let's change the color really fast. Then we have our y. We add our exponents. 8 plus 6 is going to give me a 14 as well. So this is going to be y to the power of 14. And so this is my answer. All right, so the next one, and it's a little hard to see on here, but on your paper it should be a little bit more obvious, but this is actually a negative 4, and there's a couple of different ways that we can deal with it, but really, again, the easiest thing to do is to go ahead and do the distributive property. So I'm actually going to zoom in on this one a little bit. It might not show up on y'all's, but it'll show up for me, so anyway, I distribute that negative 4. So this is going to read as 2, all right, so it's a little small, but you'll survive, 2 to the negative 4th power, I'll deal with that in a second, times x, all right, negative 2 times negative 4 is a positive 8, all right, that worked out for me pretty nicely. Y, 3 times negative 4 is negative 12, and then z, I don't have an exponent, so it's understood 1. 1 times negative 4 is negative 4. So I have 1, 2, 3 negative exponents that are unhappy. They need to be rewritten in the denominator. So I'm going to rewrite this as my x to the 8th stays in my numerator. So I'm going to rewrite x to the 8th in my numerator. My 2 to the 4th is brought downwards. My y to the 12th is brought downwards. And my z to the 4th. Now, please make sure that when you're doing this, you are ensuring that when you move something, when you flip something, your exponent changes the sign. Because, again, the whole purpose of moving it was to make it positive. And so if you don't, you might accidentally do the work twice, and you'll get the wrong answer. So then the last thing we have to do is just ask ourselves, what is 2 to the 4th power? Well, 2 to the 4th power is going to give us 16. So I'm going to rewrite this, x to the 8th. Nothing's really changed with that. 16, y to the 12th, z to the 4th. And this is my answer. All right, underneath is a power raised to a power raised to a power. There's a lot of things happening. So what I'm going to do is I'm actually just going to deal with the two exponents next to each other right off the bat. This is going to give me 2 times 3, a 6. So it's going to say 3x squared times y. Okay, so nothing has really changed here. I've just dealt with the 2 times 3, and it's been to the 6th power. Now I'm going to distribute that to everything. So it's going to say 3 to the 6, and then, x. 2 times 6 is 12, and then y, there's an understood 1 here. 1 times 6 is 6. All right, and then again, use your calculator, figure out what is 3 to the 6th power. You should figure out with that, it is 729, and then we just carry our exponents with our variables. And this is our answer. So we're going to skip all the other ones for now, and you should be able to get the CUDA worksheet, which is called Properties of Exponents. This is our 5-2 worksheet. So it's a Properties of Exponents, and really this is from Algebra 1 because we just want to make sure that we have the rules down before we start adding other pieces. So if you have any questions, be sure to ask me when you see me tomorrow or whenever you see me. Make sure you come to help class if you need it, and I hope you have a great day.